Good day everyone. Our topic for today is all about alternating series, ratio, and root test. What is alternating series? An alternating series has terms that alternate between positive and negative, or it may or may not converge. For example, 1/2 minus 1/4 plus 1/8 over minus 1 over 16 plus and so on is equal to 1/3. This illustration may convince you that the terms converge on 1/3. As you can see in the illustration, 1/3 is at the center. So, it means that the terms converge on 1/3. Next is, this one converges on the natural logarithm of 2. Summation from n is equal to 1 to infinity times the quantity of -1 to the raise of n plus 1 over n is equal to 1 minus 1/2 plus 1/3 minus 1/4 plus 1 over 5 and so on is equal to n quantity of 2. To show why, first we start with the square of area 1 and then pair up the minus and plus fractions to show how they cut the area down to the area under the curve y is equal to 1 over x between 1 and 2. As you can see in the illustration, y is equal to 1 over x, that is 1. Then 1 minus 1/2 plus 1/3 and so on, and then etc. So, ratio test. Let summation from n is equal to 1 to infinity an be a series with non-zero terms. Let p is equal to limits from n to infinity, the absolute value of an plus 1 over an. First, if 0 less than equal to p less than 1, then summation from n is equal to 1 to infinity an converges absolutely. Second, if p is greater than 1 or p is equal to infinity, then summation of n from n is equal to 1 to infinity an is diverges. Third, if p is equal to 1, the test does not provide any information. Please remember the terms of ratio test. For example, for each of the following series, use the ratio test to determine whether the series converges or diverges. A, summation from n is equal to 1 to infinity to 2 the raise of n over n factorial. B, summation from n is equal to 1 to infinity n with the power of n over n factorial. C, summation from n is equal to 1 to infinity times the quantity of -1 to the power of n 1 times the quantity of n factorial to the power of 2 over quantity of 2n factorial. So, let's solve the problem. From the ratio test, we can see that P is equal to the limits from n to infinity to n plus 1 over the quantity of n plus 1 factorial over 2 to the power of n over n factorial is equal to limit n to infinity to n plus 1 over the quantity of n plus 1 factorial. Since is equal to n factorial over 2 to the power of n. Since the quantity of n plus 1 factorial is equal to the quantity of n plus 1 times n factorial, so the P is equal to limit n to infinity 2 over n plus 1 is equal to 0. Since P is less than 1, the series converges. Diba ang ingon dito sa ratio test on how to know the ratio test, diba? If 0 is less than equal to P or less than 1, it is converges. Pag P is greater than 1, it is diverges. If P is equal to 1, that is, does not provide any information. So, in this problem, the answer is 0. So, P is less than 1, so the series is converges. Next is, we can see that P is equal to limit n is to infinity n plus 1 to the raise of n plus 1 over n plus 1 factorial over n to the power of n, divide n factorial is equal to limit quantity of n plus 1 to the power of n plus 1 over n plus 1 factorial times n factorial over n to the power of n. So, it is equal to limit from n to infinity n plus 1 over n times n is equal to limit n to infinity times the quantity of 1 plus 1 over n to the power of n is equal to e. Since P is greater than 1, so the series is diverges. Since quantity of negative 1 n plus 1 to the power of n plus 1 times the quantity of n plus 1 times factorial to the power of 2 times over the quantity of 2 times the quantity of n plus 1 times factorial over the quantity of negative 1 to the power of n times the quantity of n factorial to the power of 2 over the quantity of 2n times factorial. So, it is equal to n plus 1 times factorial times the quantity of n plus 1 factorial divide or over the quantity of 2n plus 2 factorial times the quantity of 2n factorial over n factorial n factorial. So, it is equal to n plus 1 the quantity of times the quantity of n plus 1 over 2n plus 2 times the quantity of 2n plus 1. So, we see that P is equal to limit from n to infinity the quantity of n plus 1 times the quantity of n plus 1 divide or over the quantity of 2n plus 2 times the quantity of 2n plus 1 is equal to 1/4. Since P is less than 1, the series is converges. Next example. Use the ratio test to determine whether the series of summation from n is equal to 1 to infinity n to the power of 3 over 3 to the power of n converges or diverges. Hint is evaluate limits from n to infinity, the quantity of n plus 1 to the power of 3 over 3 the power of n plus 1 times 3n, 3 or 3 to the power of n, divide n to the power of 3. The answer is converges. Next is consider the series summation from n is equal to 1 to infinity an. Let p is equal to limit n is equal to 1. Square root of absolute value an. So, first is if 0 is less than equal to p, then it is converges. Second, if p is greater than 1, diverges. If p is equal to 1, that test does not provide any information. The root test is useful for series whose terms involve exponentials. In particular, for a series whose terms an satisfy the absolute an is equal to quantity of bn to the power of n. Then, square root of absolute an is equal to bn, and we need only evaluate the limit from n to infinity, bn. Example. For each of the following series, use the root test to determine whether the series converges or diverges. A is summation n is equal to 1 to infinity, quantity of n to the power of 2 plus 3n to the power of n over quantity of 4 n squared plus 5 to the power of n. Second, or letter B, is summation from n is equal to 1 to infinity, n to the power of n, divide n, the quantity of n times the quantity of n to the power of n. To apply the root test, we compute p is equal to limit from n to infinity, the square root of n times the quantity of n squared plus 3n to the power of n times the quantity of 4n squared plus 5 to the power of n is equal to limit n to infinity n squared plus 3n over 4n squared plus 5 is equal to 1/4. So, since p is less than 1, the series is converges absolutely. We have 0 is equal to limit from n to infinity, the square root of n to the power of n, divide n to the power of n is equal to limit from n to infinity, n divide n is equal to infinity. By L'Hospital's rule, since p is equal to infinity, the series is diverges. Another example. Use the root test to determine whether the series summation from n is equal to 1 to infinity, 1 over n to the power of n converges or diverges. Hint. Evaluate limits from n to infinity, the square root of 1 over n to the power of n. So the answer is converges. So that's all. I hope you understand my discussions, and God bless you all and stay safe.